Okay, so in this video, I will show you how you can get your cases, FSI cases, that is, to run on the cluster. So I do expect you to have set up your case, to have started it at least in a test run on your own computer, and that you do know how to do that before you go to the cluster. In order to access the cluster, you need to be on one of the university workstations, i.e. in the university network, or if you want to access it from home, you need to use the virtual private network. The instructions on how to use the virtual private network and how to install it on your computer and how to use it are on the student's intranet. So you need to check there and follow the instructions for your tool. You will then have to log in, and after you log in with a VPN, you can then connect to the cluster. I will have sent you the cluster login data in an email. So it's your student username and password that I will send you in an email. The program that you can use to get the case to the cluster is Filezilla. That is also available via Apps Anywhere on or the Shoe workstation. So when we start Filezilla and go to our case files, it's in Workspace, Resize Cases, and here I have set up the Lee 2012 case, and in here we need to insert the host name, username, and password for our server. So that is hpc.hallam.shu.ac.uk. The username is your username. I'm going to use Archie's username here. And the password is that cryptic string that we entered, and the port that we need is 22. And then click Quick Connect. It will ask you to trust this host. So it will tell you what is its encryption fingerprint. You accept that, and then you have connected. So on the left side now you have your local directories, and on the right side you have the directories on the cluster. I want to copy the case into the precise cases folder, which has this tools directory in it, which you will need. So copy it over is simply drag and drop, and it will copy all the data over. And this is also how you can later get the data back from the cluster to your local computer. So I'll close this now. Not what I wanted, wrong key. So let me close this, and then we need a terminal, and in that terminal we need to connect to the cluster. So you can do that from your Linux or system, or you can do that using an SSH client like PuTTY, or you use your Windows subsystem for Linux installation to connect to the cluster. So if you are working on a Windows system, then you may have to download a program that is called Putty, P-U-T-T-Y, and that will allow you to connect to the cluster in a terminal on the cluster. I'm on a Linux system, so that works transparently for me. So when you enter your password, you get the login message of the cluster, and we are now on the cluster and can work on the cluster as if it was your local system, but without any graphical user interface. You will remember that I asked you to go through a little course on the fundamentals of command line usage, and this is the point where you definitely need that, because now we don't have any graphical tools on this high performance computer, but we need to work on the terminal alone. So we need to go to the case that we looked at, and the command for that is cd, change directory, resize, cases, Lee 2020. You can use tab to get the completion in this, on these terminals. Then let's have a look what's in there. That's ls. ls minus l gives you the long version of that. So the ls command is the list command. So we do have the Salome directory, which contains all the geometry and the meshing parts that we did. We don't need that on the cluster, but we copied that in here anyhow. We have a fluid OpenFOAM, solid Calculix, and we set all that up before, the precise config XML. So in the last videos, we set that all up and ran it on our own computer. And we now need to run it on this computer. In order to run that, what you need is a run file. And that run file is going to be in your home directory. In this case, I had forgotten to link that to the run script that is in my home directory, but that link I have now just created off screen. So now you see this run FSI sh in your home directory, which is the script that we need to give the cluster to actually run your case. So let's have a look at what is in there, and let me also show you how you can edit text files on the cluster. Since we only have a terminal, you cannot use your graphical text editor with all the nice GUI. So there we need to use a terminal-based editor. The easiest to use for beginners is Nano. So that's the name of the editor, and then you just give it the file name. Other editors are also installed. My favorite for terminal work on remote servers is VI, but maybe read the documentation of that before you go and open a text file in it, because there are rumors that people have taken years to find out how to exit that editor. So nano run fsi.sh, and that will open the text editor. In this case, you will also get a warning that you don't have write permission, because this is a file that I prepared. So if you actually want to use that and change it, you need to copy it first, because this is my run file that I have as a template and that I linked into your home directory. But if you want to copy that, then you can change it. Let's have a look at how these scripts look like. The hashbang bin bash in the first line tells it to run on the born again shell, which means it's a shell script. And a shell script is basically just a collection of commands that you would enter into the shell, i.e. the terminal, in order to get things done. So when we go through this, it's basically just commands one after the other. The hash mark marks comments. So this is a comment line. The hash with a bang after it tells the code, tells the shell what shell to start to run this script. So that's a special line. So that's not a comment in the usual sense, as is the hash sbatch, which gives the batch processor or the load leveler that distributes the cases around the cluster some data. So these are comment lines. These are data or parameters, setting parameters for the Slurm load leveler. So the Slurm is the job manager on the cluster, and that distributes the jobs that we sent. And this file is the file that gets run once Slurm has distributed the cases. So this is the file in which all the commands are located that you would run in order to get your case started. So this first one reads your shell configuration. So there are some settings in there that we need. So this command needs to stay in there. The cluster has several modules that you can load in, but for the time being, you don't need that because all the modules you need I have pre-included in your bash RC. We need to set a library load path because the software needs to use some additional software / library functions and it needs to know where to look for that. So don't change this one. And from here on, it does basically what you already know and what you do when you start the case by hand. So this reads your OpenFOAM configuration and sets up OpenFOAM. This is an if statement. So if you give the command an argument, then that means you run that, then it takes that argument and interprets it as the path where that case should be run. So you can simply give the run fsi.sh space and then the path name where your case is located. And we're going to do that later. This is something that I don't need anymore, so I put a comment in, but I'm not sure if I'm going to use it later. So that's how you can have scripts where you have reserve commands in it, but never mind this one. That's an alternative of giving the case here. And then we start foam, and we started in parallel. And before we started, we need to change into the fluid open foam directory. So here, this if statement, if you give it a parameter, then we change into that directory. If you don't give it a parameter, or if the parameter is not a path, then it will stay in the current directory. So in any case, and then you need to start this from the directory where you are, where you have the case. So in any case, after this, we're going to be in the directory that your case is in. And in that directory, if you remember, we have two directories, Fluid OpenFOAM and Solid Calculix. And in each of these, we did start the case using the run.sh script. So to start foam, we change into the directory Fluid OpenFOAM, cd Fluid OpenFOAM. We then start the run shell script as we did it by hand in the last video. So that is run.sh minus parallel. And then this is a redirection command. So that takes the output and writes it into a log file. And the log file is located in the directory where the case is. So that is going to be called a job ID, which will be a number, and .fluid.log. So that is where the output of OpenFOAM goes. And then this ampersand tells the shell to not wait for this job to finish, but to continue executing this script. Otherwise, it would wait for Calculix to get started in a different shell. So we need this in order to be able to start Calculix. So the first part that you start of this those two jobs, that needs to be started in the background, as we see. So that needs to have this ampersand in here, and then we start calculus on a single processor, so we don't do it in parallel. So we now do a cd / solid calculus, because we are now in the fluid OpenFOAM subdirectory. So we need to go one directory up and then into the solid calculus directory. So that's what this cd does. And then in that solid calculus directory, we do run shell and another redirection into another log file. Note that we don't have the ampersand at the end of this one. So in order to exit Nano, we need to read what's at the bottom of the screen. The hat means the control key. So this little menu down there tells me that if I hit Control X, both keys together, then I will exit that editor. So Control X. Save modified buffer. I'm not going to be able to do that, so I say no. So now I have this script not changed. So this is the script that I want to run. So how do I do that? I first need to see what number of processors I need. So remember we used decompose par. So if I go to the case file, resize, cases, fluid OpenFOAM system decompose par dict. That is the file that tells me how many processors I have. Less is just a command that allows me to look at files. I could also use Nano if I wanted to change it. So let's use Nano. So I can actually change the file. So in this file, we are looking at how many subdomains do we want. So we have 4 subdomains, which means we have 4 processors for OpenFOAM. And if you use the simple method, then you need to give it these coefficients, and these are the X, Y, and Z direction. So you need to tell it how it is supposed to separate that. I personally prefer the Scotch method for this. So let's just change that. Scotch doesn't need any coefficients. So if you use Scotch, then you can just change the number of subdomains, for example, to 8, and then you have 8 processors. So, but let's stick to 4 for the time being. So if I Control X that, then it will ask me buffer. I save, and then you just need to confirm that to save it to the same file name. So if I do that again, then you see it is now that one that I have changed. So now we know that we use 4 CPUs. That means OpenFOAM is going to use 4 CPUs. Calculus is going to use 1 CPU. However, Calculus can use threads, so it can use basically 2 CPUs. So 4 plus 2 is 6. So I now need 6 CPUs, and I need to ask the cluster to give me 6 CPUs to start this case. And the command to start or to send the case to the cluster is sbatch, means slurm batch. So ask slurm to start to send this off in the batch process. -n is how many CPUs do I need? And remember 4 plus 2, so let's ask for 6 CPUs here. And then I just give it the script. So there's 2 ways to deal with this now. So I can change into the directory where my case is in and then issue this command, or I issue the command from my home directory, for example, and then simply tell it where the case is, which is what I'm going to do now. So that is where the case is, yeah. And if I start this, then it tells me submitted batch job 52785. The command how I can check what's it doing is SQ, and I see it has not worked. So something's wrong. So let's have a look. Oops. Oh, I did make a few last minute changes, so maybe that is the problem here. Permission denied. That is a problem that I can fix, but you cannot. So let me connect with my user account here. Okay, it's a bit weird. So what you can do is just copy that run FSI shell. And I think that is the better way to do it anyhow, to treat this run FSI shell as a template. Oh, dot run shell, permission denied. Wait a sec. It's not this case, this run script, but it's the run shell in the case file that is not allowed, which I think is something that Filezilla messed up. I don't usually use Filezilla. So in order to fix that, we need to tell it that it's supposed to be allowed to execute these. So let's have a look. ls-l. Yeah, you see run.sh does not have the X here, which would be the executable bit. So to change that, we do changement plus X /run shell. And now when I do an ls-l, we do have these executable bits. This seems to be something that Filezilla changes, because definitely on the case that we copied over, it did have that run.sh as executable. And we need to do the same on the solid calculix bit. Changemod plus X /run sh, and now that is executable as well. So going back, starting that S batch again. But first of all, let me see why this isn't working. I think it doesn't know the Slurm job ID. So I need to find a better way to do that, but that's not your problem now. sbatch -n6, that from there we are. Sbatch -n6 run FSI shell precise cases Lee 2012. So let's see if this works now. SQ now is running precise job with that username. It's running for 9 seconds so far, 16 seconds. So this is looking good. ls-l tells me we don't have anything in the output file. We don't have anything in the error file, which is what we would expect, because the output is going to go into the case file. So precise cases Lee ls-l, and here you now see the fluid log and the solid log. These are the ones from the failed attempt. They're empty, so we can delete those. rm 52785. So let's delete those. now we have these two logs, and we can, with the tail command, keep an eye on what these do. So I can, for example, look at the fluid log, and that is the output of OpenFOAM as it is running. And I can have a look at the solid.log, and that is the output of the Calculix solver as it is running. And you remember how that looked like in the two terminals that we had. So we can open a second terminal on the cluster and keep an eye on these files as well. So this is now going to take a while. And if you have a very fast PC yourself and have a Windows subsystem for Linux installation, or even a Linux installation yourself, then you will notice that the cluster is a bit slower than your computer may be. The cluster nodes are 6-year-old Xeon processors, which were very much state-of-the-art, but typically clusters are run for quite a long time. So the benefit here is not necessarily pure speed, but the benefit here is that you can leave it running for days on end, and that you can have access to more than the CPUs that you would have on your own computer. So if you're running smaller cases and it's all about getting the quickest turnaround, then maybe your own computer will be quicker. But if you want to run 3-4 cases in parallel or at the same time, then definitely going to the cluster. Or if you have your computer in your bedroom and you want to get a good night's sleep without the fans blasting at full beans, then going for the cluster is definitely a good idea. So this is how you can start the case on the cluster. You will, in order to get out of these tails, you need Control-C. And if you go back to the cluster, you can run an SQ. So check in every couple of hours and see what it's doing. And you will see this one has been running for 3 minutes 15 so far. So other cases have been run for 16 days, 17 hours here, 7 hours, 7 days, 5 hours. So this is definitely something to run long cases on. So for your test case, that may not be required. The test case on this cluster should run with 4 CPUs in about 5.5 hours, which is a bit longer than it ran on my equally not most modern 4th gen i7 that I'm running here. So cluster is not the fastest, but it's definitely a good idea to go to the cluster for those long running. And you can run the case on 8 CPUs, 12 CPUs, 16 CPUs, etc. And that will speed up quite a bit. So if you then come back and this SQ is no longer there, then it's definitely a good idea to look at the error file, which should be empty, and to look at the log files here, which should have the information about the last time step at the end. The best way to look at log files is usually the tail command, which just gives you the last few lines. And then with the -F option, it will keep following that command. Or you use the less command, which will give you the log file from the beginning, and you can see everything that has been going on. In less, 2 important shortcuts are GG to go to the top and Shift G, capital G, to go to the bottom. And you can also say 1000, which gets you to line 1000, but whoever knows where that is. But G and GG is quite handy to see, okay, where are we and where did we start? And if you want to search in there, that's the slash, so I can search for time. That will give me all the occasions or occurrences of time, and then I can use N to go through there, for example. So if I want to see which time steps I have, then I can just do time space or backslash space, I think it is, and then just go through the time step. So that's a little trick on in less, and if you want to exit less, it's Q again. So this should give you everything that you need to run your cases on the cluster. If you haven't done so, follow the link that I gave you for the short introduction into terminal or text user interface commands, command line shell commands, because now is the time when you're going to use them. So thank you very much and have fun.